Hi, so in the previous video, I just introduced everything, and now we're going to go through 3 different examples, one video per example. So this is example 1 here. I'll read it out, even though, of course, you could just pause it and read it for yourself, but, what do you do? 6 cards are randomly drawn from a standard pack of 52 cards. Determine the probability that exactly one of the 6 cards is a queen. Now, from what I understand, it's really rare to get a cards question in the exam because they're not too sure what people know about, and cards is one of those things you do or you don't know about, but it is pretty frequent in textbooks when you can look it up. So just a reminder, you should know by now, 52 cards, 4 suits, of which there are 13 in each: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Ace is sometimes called a picture card, sometimes it's not. Sometimes the rank of ace is at the bottom, sometimes the rank of ace is at the top, so it becomes a little bit random as to what the meanings might be depending on the game as well. Sometimes the picture cards are worth 10, sometimes they're worth 10, 11, 12, 13, so it goes on. So 6 cards are randomly drawn. Okay, so I'll just go down to slide 3 to do this. Now, I should say that most of these sorts of things we'll use calculators. I've got off to the side here all the calculations done for me previously, so I don't have to waste your time by looking at the GDC, flicking between the screens and stuff. That's what you're effectively doing, and I'll highlight when that happens. So we need the probability of 1 queen only. So we don't want more than 1 queen. So what we're doing really is we're trying to determine what we've done from probably since grade 8, and that is, what are the desirable outcomes? That's the top number, or the matching outcomes, and what is the total number of outcomes? Now, conceptually, I might just do the bottom first so you can sort of see it, which is the total outcomes, remember? So there's my denominator, there's my fraction bar. What's the probability, or how many different ways can I select 6 cards at random? Well, I've got 52 cards, and I'm going to choose combinations of 6 cards. So 52C6 becomes the total number of ways I can draw 6 cards from a standard pack of cards. Now, what about the top number? The top number is effectively, if we set it it's always good if you can re-say the statement that you're given in the question as a series of ands or ors, because ands means multiply and ors means add. So if I said getting exactly 1 queen, I would be saying I get 1 queen and the rest are not queens. 1 queen and the rest are not queens. So how many ways can I pick 1 queen? Well, there are 4 in the deck, which means that there are 4 queens. Choose 1. In other words, you might know by now that 4C1, NC1 is always equal to N. So 4C1 would just be 4, which kind of makes sense. There are 4 queens in the deck, so there are 4 ways I can choose it. And then the rest have to be not queens. So if I take out those 4 queens from the deck, what am I left with? I've got 48 queens left. Sorry, 48 cards left. And I'm going to choose, it would say 6 cards, isn't it? So I've already chosen a queen, so that means the other are not queens. So I've got 5 that are not queens. Now, again, this does not mean the first card is a queen and the rest are not. It just means out of the 6 cards, 4 of them, 4C1 is the number of ways I can choose one of those cards to be a queen, and 48C5 is the number of ways I can choose the other 5 cards. Okay, order doesn't matter. And this kind of makes sense too in terms of this being a multiplication. The commutative law for multiplication means it doesn't matter which way you multiply them. So that's why this works. Okay, the rest is a calculator operation. So I'm going to write down what it says. I would probably go straight to the answer for this, but just so you can sort of get a sense of the size of the number, 4C1 is 4. And then the calculator tells me that the number is 1.7123. Hang on, that doesn't seem very big. E6, it says on my calculator, so that's 10 to the power of 6. In other words, I moved that decimal point 6 places to the right to say how many ways I could choose 5 from 48. So it's huge. And then on the bottom, I've got 2.0358. 5 times 10 to the power of 7. So that's a pretty huge number as well. So again, just to point out, I'm just spelling that out a bit for this video. The other videos won't be quite so long-winded. That is number of ways of choosing 5 non-queen cards, and that is number of ways of choosing the queen. And so that becomes that, and that becomes that number. And this here is number of ways of choosing 6 cards. Oops. Whew. Okay, what does all that mean? It means blip, 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 blop on your calculator, and you get 0.33643. There you go. So that's the answer. If you wanted it as a fraction, I believe this is right. I think it's 18,216 over 54,145 is the fraction. In the next video, I might show you how to use your GDC to turn a decimal number into a fraction, with a couple of caveats. If you don't have your calculator in exact mode, it will give it to you as a decimal. So you can use your calculator to convert it back into a fraction if you need to, and I'll show that in the second video. That'll do for this one. See you next video.